Light rain over the Madrid tracking station of the Deep Space Network on the 26th of October didn't stop the data from arriving, a few hours only after the flyby. On the first of its 45 encounters with Titan, the Cassini-Huygens mission had observed Saturn's giant moon at close quarters. At the Jet Propulsion Laboratory, scientists waited patiently as the data were received and displayed, but apparently Titan was keeping many of its secrets.
Last night, the solar system became a smaller place, and as we conducted our first very high-resolution reconnaissance of the Titan surface, some of the images and some of the filters just showed a remarkable degree of clarity because the viewing geometry for this flyby with the sun at our back was just ideal for seeing down to the surface. However, I have to report that we are still mystified and we are not quite sure what we're looking at.
Cassini's navigation was spot on, passing less than 1,200 kilometers from the moon's surface, allowing instruments to taste the upper levels of its atmosphere and to survey one area of Titan with a remarkable clarity, with imaging resolutions up to 200 meters per pixel. Surprise, fewer methane clouds than expected were seen, but from their movement a first conclusion has been reached. Titan's atmosphere is moving faster than the moon's rotation, a so-called superrotation, like on Venus. Although the surface displays highly contrasted areas, such as this 2,000-kilometer wide view with close-ups above, scientists remain baffled.
There's sharp boundaries between the dark regions and the bright regions. The white things that stick out, they kind of look like islands sticking out of the dark material, but frankly, there's no topography in our images. We do not see shadows, and because we don't see shadows, we can't look at an image like this and immediately deduce topographic information, what's up and what's down. Everything here could, for all we can tell right now, be perfectly flat.
There's also mystery over the eventual liquids that the ISS cameras could have revealed by detecting their different specular reflection of sunlight. Cassini has observed the area in which the Huygens probe will be arriving next January, pictured here by the ISS wide and narrow-angle optical cameras, and in this false color image provided by the visual and infrared mapping spectrometer. VIMS has offered clear views on the right at a wavelength of 2 microns of Titan's complex landforms with sharp boundaries, whose surface composition has to be fully understood.
Molecules have specific spectral signatures, and that's what we were looking for. We were looking through the spectra to see what we call absorption features, which are specific to a given molecule, and so far we haven't been able to pick anything out which would allow us to point at something and say, aha, this is what it is. And in fact, we're backing away from what we had said earlier, and that is we thought the dark areas were composed of water ice. We don't have evidence in this latest flyby to support that kind of tentative conclusion.
Many of the ISS images provided during the flyby show linear features, grooves, striations or fractures, who knows, most with a similar east-to-west orientation. The spacecraft's iron and neutral mass spectrometer has obtained the first in-situ indications on the hydrocarbons in Titan's atmosphere, with unexpected high amounts of heavy compounds such as benzene and diacetylene.
The fact that we saw it at 1,200 kilometers is kind of surprising. Most atmospheres are mixed, well mixed, lowered in the atmosphere, and then have a region above that where they just separate by mass, and so heavy species are not generally found high up in the upper atmosphere. Titan seems to be mixed all the way to the top, and that's probably the most surprising aspect of it.
An extra day of processing was required before the presentation of the much-awaited radar observation of Titan, a 2,000-kilometer-long strip in the northern hemisphere, 120 kilometers wide, not yet covered by other optical instruments. A wide geologic variety is seen, bright areas corresponding to rougher terrains, darker ones thought to be smoother. Scientists describe Titan as active and youthful. It has unique narrow and very long linear features and many ridges. The surface may be covered with organic materials, but how much is solid, how much is liquid? one large dark and apparently smooth lake-like area is particularly intriguing.
The fact that it looks very dark, most likely it's very smooth. That means kind of imagine in your mind a little bit you are standing at the lake which is very calm on a calm day. Now, one thing which will be interesting is as we come back to some of these areas, at later time, if the atmospheric conditions are a little bit different, like if there is a wind pattern which is happening or somewhat, we could see a different reflection of the same area. That will be an indication that that's a very dynamic surface. Then one conclusion could be that it's being roughened because there is some wind pattern. So that could be an indication of a fluid surface.
The young daughter of one radar team member has found a resemblance, and the area has been dubbed Cece the Halloween Cat. The first encounter with Titan has placed Cassini on a tighter orbit, circling the planet now every 48 days instead of 4 months. The stage is set for another rendezvous with the Moon on the 13th of December, just a month before the Huygens probe descends to obtain the ground truth.
There's an enormous amount of additional information to come, and just the information gathered from this first flyby has been so significant in advancing our understanding of Titan that I think we can look forward to essentially revealing all of Titan's nature over the next 4 years. It's a difficult process because the atmosphere is so thick and so hazy. The surface, at least, is like a jigsaw puzzle for which the picture is not provided on the box top. You don't know what the final picture is going to look like, and the pieces have to be put together over time. I'm very confident that by the end of these 4 years, Titan will be moved from being a mysterious, hazy, unknown world to one of the pantheon of worlds that human beings understand and really come to know as their own.